Hello everyone, welcome back to Cambridge Guru once again. In the last video, we did exponential and logarithmic functions in which we studied about the graphical properties of both exponent and log functions, and in the end we also did some properties of log which will be required in solving some equations involving variable and log terms. So in this video we will solve some questions based on exponents and logs. So let us start. So the first example, as you can see, is 9 raised to power 2x is equal to 9 raised to power 8. Now whenever we are solving any equation which involves exponents and the variable is in the exponent, then two things we need to keep in mind. First thing is that if bases are same, then exponents have to be equal and vice versa. Meaning, if exponents are equal, then bases have to be same, or if bases are same, then exponents have to be equal, right? This simple rule we will follow to solve exponential equations. So 9 raised to power 2x is equal to 9 raised to power 8. As we can see that 9 is on both the sides, base is 9, so exponents have to be equal. So in this we simply say that 2x must be equal to 8. So solution is x is equal to 4. Simple. Next, again applying the same logic, e raised to power t square. This time exponents are not linear function. Exponents or the variable in the exponents are some quadratic function. So we will apply the same logic that exponents in this case also have to be equal. So t square must be equal to 4t minus 3. Now this is a quadratic equation. So let us try to solve this. T square minus 4t plus 3 equal to 0. This we can do using factorization. This can be written as t minus, I think the factors will be 3 and 1, right? So minus 3 and t minus 1 equal to 0. So the solution is t is equal to either 1 or 3. Okay. You can verify also, because in exponents the verification of the solution is also, you can say, is recommended, because sometimes it happens that it does not fall under the domain of the given function, right? Sometimes if the question involves some log functions, and we know that in logarithm only the positive values are allowed, but sometimes it happens that you might get more than one solution, and one solution is, although after solving the equation you are getting the solution of a quadratic equation or some cubic equation, but when you put those values in the original form of the question which involves log, so in that case domain matters, meaning only the positive solution will be applicable. Okay, so this thing also you should keep in mind. So if we verify this with t equal to 1 and 3, so e, when we put t as 1, so LHS becomes e, and RHS also becomes 4 minus 3 as 1. Similarly, for 3 also LHS becomes e raised to power 9, and RHS also becomes e raised to power 9. So both the solutions are applicable or will be accepted. So in the third part, it is root 5 raised to power x is equal to 125. Now logic, again the same logic we will apply, that since the variable is in the exponent, so we need to make the bases of both the sides equal. How we can do this? That as you can see in the left hand side, base is written in terms of 5, right? And also we know that 125 is a multiple of 5. So we can write 125 as 5 cube, and this third can be written in exponent form as 5 raised to power half. So I'm writing this equation as 5 raised to power half raised to power x, this is my square root of 5, is equal to 5 cube. Okay, now 5 raised to power half raised to power x, again applying laws of exponents, that x raised to power a raised to power m, these exponents can be multiplied. So LHS can be written as 5 raised to power x by 2 is equal to 5 cube. Okay, I'm deleting the previous one. right? So now the bases are same on both the sides. We can compare the exponents. That means x by 2 is equal to 3. This yields x is equal to 6. Okay. Next, b raised to power 4 is 10 raised to power 12. Now in this case, variable is in the base, it is not in the exponent. First thing is this. So we need to make the exponent on both the sides equal. Then only we can compare the bases, right? But in this case also, but exponents on both the sides are not equal. In left hand side, exponent is 4, and we cannot do anything with this left hand side because the variable is involved in this. Until unless we do not know the value of b, this will remain as b raised to power 4. So whatever modification or manipulation which we need to do, that will be in right hand side only, right? So I have to write this right hand side as something raised to power 4, right? How we will do this? You can pause the video and you have to do these questions on your own. So what we can do is, since 12 is a multiple of 4, right, like we did in the previous one, the exponents gets multiplied. So I have to write this as an exponent of some exponent so that they both multiplied. Meaning is that left hand side is b raised to power 4. This is equal to, if I write this as 10 raised to power 3 and raised to power 4, right? So my number b or the base is not 10. I will write this as 10 cube as the base and then raised to power 4. Now as you can see that if I compare the exponents of b raised to power 4 and 10 cube raised to power 4, this will simply give me the value of b as 10 cube, which is 1000. This is how you will do this. Okay, applying the same logic, in the next part we will do that both the bases are involving the variable, but again the bases are not same, right? But we can see that variable is b, so I have to write left hand side this time as b raised to power something, right? Because in the right hand side it is b raised to power minus 6. So what we will do is we will multiply this 2 with x plus 1. So left hand side will become b raised to power 2x plus 2 by multiplying this 2 with x plus 1. Okay, this is equal to b raised to power minus 6. This will give me 2x plus 2 is equal to minus 6, right? So this will give me 2x is equal to minus 8, that is x is equal to minus 4, right? Yes, absolutely. Okay, next one is e raised to power 2x is equal to e raised to power x plus 1. This is very simple, you can do this orally, right? Basis is, you can write this e raised to power x plus 1. This x plus 1 is, entire x plus 1 is in the exponent of e. Okay, so simple, 2x is equal to x plus 1. So x is equal to 1. You can verify this, that when you put x equal to 1, e square becomes e square. Okay, the next one, it is 3 raised to power x is equal to 1 by 3x raised to power x plus 1. Now as you can see here that exponents are different, but form of writing the bases, not exponent, bases are different, but form of writing the base is different. We can make the bases as same by writing right hand side with 3 raised to power something, right? We know that 1 by a can be written as a raised to power minus 1 using again laws of exponents. So this 1 by 3 is in fact written as 3 raised to power minus 1. So rewriting this equation as 3 raised to power x is equal to 3 raised to power minus 1, which is 1 by 3, and this whole raised to power x plus 1, right? So this becomes now 3 raised to power x is equal to 3 raised to power minus x minus 1, multiplying minus with x plus 1. Now you can compare the exponents. Let me omit this. So x is equal to minus x minus 1. So 2x is minus 1. So x is minus half. This is your answer. And of course, in the exponent can be negative. Okay, do not get confused about the conditions. Whatever condition we impose in exponential function, if you watch my previous lesson, we impose the condition only on the base, not on the exponent. Fine. Again, 4 raised to power minus x and 2 raised to power x plus 1, we need to make the bases as same. So 4 will be written as 2 square. So writing this as 2 square raised to power minus x is equal to 2 raised to power x plus 1. Rewriting this as 2 raised to power minus 2x, multiplying 2 with minus x will give you 2 raised to power minus 2x is equal to 2 raised to power x plus 1. So this is 3x is minus 1. So x is minus 1 by 3. Very simple. And in this case, let me go downwards. I have to solve k raised to power 3 by 2. This is a bit tricky because in RHS there is no exponent, but we remember that 27 it comes under, or 27 is a multiple of 3 also, and it is a multiple of 9 also, right? And also it's a multiple of 27 itself. But again, variable is in the same is in the base, so we need to make the exponent same. Okay, if variable is in the base, exponent needs to be same. If exponent variable is in the exponent, bases needs to be same. Simple logic. So how we can write 27 as an exponent of 3 by 2, some exponent of 3 by 2 as an exponent of some number. Okay, how we will do this? So let me adjust this, that I know that 27 is 3 cube, right? Do not write, please, do not write this 27 as 9 into 3. Okay, it is not cube of 9. Okay, cubing is something different. It is not a multiple. So 27 is 3 cube. Okay, meaning is this k raised to power 3 by 2 is equal to 3 cube. Now 3 is in the exponent of RHS. 3 is involved in the exponent of LHS also. So if I write this as k raised to power 1 by 2 raised to power 3, I have made the exponent on LHS as 3, and in the RHS also it is 3 cube. Now I have made the exponent as same. We can compare the bases. Meaning is k raised to power half is 3, squaring on both the sides, k gives you 9. Squaring both the sides. So k is 9. Right? So 9 raised to power 3 by 2 is in fact 27. Now let us solve some questions involving logarithms, right? And as you can see that this is written as ln. So it's a special case of log, that whenever we write log of a number x with base e is a special universal constant, which is Napier's constant. Its value is 2 point something. I do not know the exact value, 2.6 something like that. So just like we have pi as a universal constant, and it has some properties, how we derived the value of pi, how it is related to the geometry. Similarly, this e, the Napier's constant, it is also somehow related with some algebra also, and we normally deal with e in calculus, right? And it has some properties, right? So when the base of the log is x, it is e, we write this as, it is just a notation, log with natural base. So we simply write ln, log with natural base. This e base is called the natural base, right? So it is just a notation. It simply says that this log is now having base as e. Okay, fine. So let us come to the question. It says that log ln, we pronounce this as ln x4 minus ln x square is equal to 2. So ln x raised to power 4 minus ln x square is equal to 2. So we have learned the property of log, that log a minus log b is in fact log a upon b. So writing this as ln x raised to power 4 divided by x square is equal to 2. Now, in order to remove the log, we need to transfer the base or write this in exponent form. Okay, that is how we remove the log from an equation, right? Before that, let us simplify this. This becomes x square, right, is equal to 2. Meaning is that since the base here is e, so we can write this, transfer this base to RHS. And remember, I told you how we remember this, that this e comes under the feet of 2, or 2 is on the shoulder of e the moment we transfer this to right hand side. So it becomes e square. So x square is equal to e square. Okay, we can remove the log from this side the moment we transfer base to RHS. This is how we convert log into exponent. Okay, so as you can see that exponents are same, so bases must be same. So solution for this equation is x is equal to e, right? Okay, and last one is, let us solve it here only. It says log y with base 3 plus log this with base 3 is equal to 14. As you can see here, bases are same and you are adding two different logs. So the first property we will apply log a plus log b. But before that, we need to apply the third or fourth property, that it is directly not in the form of log b. There is 3 which is in multiplication of this, right? So before that, we need to write this in pure log form without this coefficient 3. Okay, so rewriting this equation as log y with base 3 plus, how we can write this as that this 3 can come in the exponent of y square. Okay, remember I told you that m log x can be written as log x with raised to power m. This exponent comes in the coefficient, right? I told you that log of 3 raised to power 100 can be written as 100 log 3. Right, so here we are applying the property in reverse. We are transferring back this coefficient to the exponent of whatever the number we are finding out the log. So log y square raised to power 3 is in fact y raised to power 6, right? And base is now 3. This is equal to 14. Now it is in the form of log a plus log b. This b can be in exponent form. There is no problem in this, but there should not be any term which is not term, but there should not be any number which is in multiplication of this log. Okay, now we can apply log a plus log b, which is log ab. So I can write this as log y into y raised to power 6 base 3 is equal to 14. Meaning is log y raised to power 7 with base 3 is equal to 14. Right, now the last step in log is same in almost every question, that when log of something is equal to some constant, we need to write this in exponent form, right? Meaning is y raised to power 7 is equal to 3 raised to power 14. This comes under the feet of 14. Now this becomes now an exponential equation, right? Now how we solve exponential equation, which we have done in the past 10 to 15 minutes, we need to make the exponents as same because variable is in the base. So y raised to power 7 will remain as it is. I need to write 3 raised to power 14 as something raised to power 7. As we know that 14 is a multiple of 7, I can write this as 3 raised to power 2 raised to power 7. Taking out 2 as a common factor and writing it in the base. Comparing this gives you y is equal to 9, 3 square, because exponents are same. Okay, so this is how you solve questions involving exponents and log. Okay, after all, in log also we need to convert the equation into exponent form, right? So that's it. I think just to understand the concept of exponents and log, these questions are enough. That's it for today, and just wait for next video. Till then, enjoy. Bye. Thank you.